We're going to do a probability review. So these are the things you should already know about probability, and we'll get a bit rusty, so let's go through them. Before we get into the content, I would like you to have a look at the elements there, the 7 elements in bullet points, and I'd like you to think about each of those. So these ones here, from there to the last one there, I want you to come up with one event for each. One event that you could describe its probability as either an impossible chance or an impossibility. Then another event has a very low chance, etc., etc., right up to the last one, something that has a certain chance or is called a certainty. So one event for each of those. So pause the video now and write down an example for each of those. Now that you've done that, let's have a look at some terminology. So a random experiment is important to identify and maybe even design, and we have a random experiment when the results happen without interference or there's no conscious decisions. It happens purely by chance. So outcomes happen purely by chance only. The sample space is the list of all possible outcomes. So it's a list, and we often use brackets for sample space. So any type of event or outcome that's possible from an experiment goes in the sample space, and we use those curvy brackets there to write that set down. We'll see that in an example in a moment. The word event, when we're looking at probability, is basically a collection of outcomes. So they are the things that happen in an experiment. Something that happens is an event. Rolling a die is a random experiment, and the 6 possible outcomes there, and that makes up the sample space. The event rolling a number greater than 4 includes the outcomes 5 and 6. So the event is rolling a number greater than 4, and the outcomes that would go into that would be 5 and 6. This is an example of a compound event because it contains more than one element from the sample space. So compound means more than one. The probability of an event where all outcomes are equally likely, and that's not always the case, but we're going to look at easy ones first. So where everything is equally likely is this formula here. You should have seen it before. It's very important. So probability of an event, that's what the PR stands for. PR stands for probability. Probability of an event is the number of outcomes where event occurs over the total number of outcomes. Sometimes we use shorthand, and instead of probability of an event we just put capital P, and if we're rolling a number greater than 4, like that example, we might just use some math symbols to keep it short, and we would write it like that. Bit of shorthand. The probabilities must range between 0 and 1. So if something is impossible, it has a probability of 0. If it's certain, it has a probability of 1. Most things are in between this. Very few things are impossible and very few things are certain. So most things are going to be a number between 0 and 1, like 0.55. Sometimes we can write it as a fraction. Occasionally you'll see it converted to a percentage. So probability of all events must be between 0 and 1, including 0 and 1. And this links to the quiz you did when you paused the video just before. There's our probability scale. As you can see, things that are impossible have a 0 probability, things that are certain have a probability of 1. In the middle we've got even chance, which we might call 50-50 in everyday language, but it has a probability of 0.5. Things down this way have a low probability of occurring. Things up this way have a high probability of occurring. Lastly, we have the complement. Now that's an important word. The complement is basically all of the opposites. So the complement of the probability of A occurring, the complement would be the probability of not A occurring. We get the complement by going 1 minus the probability of a certain event. So simple example of that might be, very simple example is we're tossing a coin, and basically the probability of not tails, which we would put, that would be the probability of a tail. So the probability of a not tail would be T with a little bar on the top, or it could be probability of the T with a little dash there. That means complement, and that would be 1 minus the probability of getting a tail on the coin. Okay, so that's complement, and it's all of the other outcomes. Quick example here, we have a spinner. You can see there it's got all the sections are equally likely, equally divided sections. List the sample space. Okay, so sample space here, we can use capital S for sample space. Remember, we use the curvy parentheses. What have we got? If we start with the yellow sector, we have 1, 2. Now we've got 2 3s, but we only list it once because it is the same outcome, even though you could probably intuitively tell that it's going to be more likely to happen because there's 2 of those sectors we only listed once, and the other one is 7. There's no 4, 5s or 6s there. So that's a list of all the possible outcomes. You wouldn't list 6 there because, well, 6 can't happen. 6 isn't on there, so it's not part of the sample space. Probability of getting a 3, so we write probability of getting a 3. Probability of getting a 3 is the number of 3s over the total number of outcomes. So that's your rule, and that's a bit like the rule we saw just before. I've just reworded it a bit to be shorter. How many 3s are there? Well, there's 2. And this is all equally likely, so we can use this rule. How many total outcomes are there on that spinner? Well, we've got 1, 2, 3, 4, 5. So it's 2 out of 5, or 2/5. You don't have to write it as a decimal if you don't want to. You can leave it as a fraction. Simplify those fractions. Probability of not a 3. So that's probability, it's a complement, not a 3, is 1 minus the probability of a 3, which is 1 minus 2/5 that we just saw, and there's 5/5 in a whole, so there's 3/5. Part D, probability of a 3 or a 7, so probability of a 3 or 7. Now we'll accept either of those, so we need to add them up. So we need to look at the number of 3s or 7s. So I'm using this formula here again, even though I'm not writing it down a second time. So we've got the same formula. Now how many 3s or 7s are there? There's 1, there's 2, and there's 3. They're all equally likely. So there's 3 of those out of a total of 5. So that's 3/5. Probability of a number which is at least 3. So it's probability of a number that is 3 or greater. So that's greater than or equal to 3. And same formula. How many are 3 or greater? We include 3. Well, that's the same as the previous one. 3 or 7 is at least 3. So that's the same answer.